Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 9.1 entitled Square Roots. And today we're basically going to find the square root of a given number. But before we can do that, we have to talk about what a square root is. And a square root is basically a number that if you times it by yourself, you get a certain number. And that number is going to be a perfect square. So if you had 5 squared, you would get 25. So when you take the square root of 25, you get 5, because 5 times itself equals 25. So 5 is the square root of 25. Okay, so that's basically the thought process and the connection there for what a square root is. And there are a lot of characteristics about square roots. You can have positive square roots or you could have negative square roots. And that is because if you take the square root of a number like 16, you get 4, because 4 times 4 is 16. But you also get negative 4, because negative 4 times negative 4 is 16. So 4 times 4 is 16, and negative 4 times negative 4 is 16. So technically, when you take the square root of a number, you get a positive and a negative value. And when you take the square root of 0, though, you just get 0. So it only has one square root. All other numbers, all other positive numbers, are going to have 2 square roots. And if you try and take the square root of a negative number, that will be no solution. So if you try to take the square root of negative 81, 9 times 9 is 81, but you can't find a number that if you multiplied it by itself would get you negative 81. Like if you tried 9 times 9, you'd get positive 81. And if you tried negative 9 and negative 9, you'd get positive 81. So you'd need one to be positive and one to be negative, but then you're not multiplying the number by itself because you're changing the signs on there. So when we have the square root of a negative number, we say that there's no solution. Now there was a mathematician who came up with a way around this, and he took out the square root of the negative, or the square root of the negative 1, and he called that an imaginary number. So when you get to Algebra 2, they'll talk more about what imaginary numbers are and how you can get around this. But for right now, just know that when you take the square root of a negative number, it's no solution. Now, we'll have to know our perfect squares as we go through this chapter. And the perfect squares, we're just going to generate a list of them by taking a number times itself. So if you start with 1, you get 1 times 1 is 1. 1 is technically a perfect square, but it doesn't really help us reduce anything. So we're going to skip 1. And so we'll start with 2 times 2, which is 4. Then 3 times 3 is 9. So 4 and 9 are going to be your first 2 perfect squares. And then we'll have 16 and 25 and 36, 49, 64, 99 is 81. You get 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. Now that list can keep going on and on and on forever, but these are the most frequent perfect squares that you're going to see. Anything beyond 225, you would want to put into your graphing calculator or your calculator and see if it is a square root first, if it is a perfect square first. Okay, but these from 4 through 225, these we expect you to have memorized, or at least know how to generate the list of them. And you can write this at the top of your homework or the top of a quiz or a test if you'd like. Okay. Now, a couple more vocabulary words. If you can take the square root of a number, then your answer is rational. So that means like if you can take the square root of 36 and you get 6, it's rational. It makes sense. If you're a rational person, you make good decisions. You make sense. Okay? So when you take the square root of 36, you get 6. If you can't take the square root of a number, meaning like it doesn't have a whole number when you take the square root of it. Like if you take the square root of 7, you're going to get a decimal. Okay? So if it's not a whole number, then that's going to be an irrational solution. Okay? So if you're an irrational person, that means that you don't make sense, you don't make good decisions, you kind of act randomly, okay? And that's kind of what this number does. Square root 7, you can't reduce him. He's a decimal. It's kind of hard to work with sometimes, okay? So that's the difference between a rational and an irrational number. And remember, you cannot take the square root of a negative number. I've shown that to you twice now already, okay? So if you have the square root of, oh, I don't know, negative 4, okay? You're just going to say that that is no solution. And if you put that into your graphing calculator or your calculator, it'll give you an error message. So that should remind you that that's no solution. Okay, so let's talk about some basics here where we're just going to evaluate some expressions. Okay, now when you take the square root of 9, you have to think, okay, what number times itself will get me 9? And that number is going to be 3. Now I think I mentioned before how when you take the square root of a number, technically you get 2 answers. There's a positive one and a negative one. So if you wanted to write this as plus or minus 3, that would be correct as well. Okay, if you have a negative out front of your square root, just take the square root of the number that's inside the square root and then make your answer negative. So the square root of 81 is 9. So then you just leave the 9 or the negative out front of the 9. So you get negative 9 for your answer. Same thing with the little plus or minus. If there's a little plus or minus out front, you evaluate your square root. The square root of 64 is 8. And then you'll just leave the plus minus out in front. But now when you have a negative inside the square root, that's a problem. That's where you have no solution. So you cannot take a number times itself to get a negative 25. Okay, so I'll have some problems like that in your homework where they just want you to pay attention to the signage out front of the radical. And then example 2, this is just kind of a conceptual problem here. Determine if the number is a perfect square or not. So we want to think, is it on that list that we wrote down earlier in the notes that went from 4 to 225? Is it in that list? Okay. Now, the number 15 times 15 is a square root. It's a perfect square because 15 times 15 is 225. But this would be asking us to figure out if 15 itself is a perfect square. And you can't take a number times itself and get 15. So no, 15 is not a perfect square. 100 is though, because 10 times 10 is 100. Now, negative 169. 169 you might recognize as being on our list for our perfect squares, but it's a negative. Okay, so since it's negative, no, we couldn't take the square root of it. And then part D is a fraction. So you have 25 over 36, but 25 is a perfect square, and so is 36. So yes, this would be a perfect square. You'd be able to take the square root of the numerator and of the denominator. Okay, and then in example 3, they just want you to do some calculator work here. where you're going to basically type this into your calculator and then write down the answer that you get. So when you do the square root of 124, you should get about 11.14 if we rounded. Or you could write this with the little plus or minus in the front if you'd like. For part B, the square root of 18 is going to be, well, plus or minus is going to stay in the front, 4.24. And again, just do that on your calculator. These types of problems are just to make sure that you know how to enter all this stuff into your calculator. Okay, the square root of 50, even though it's negative, the negative is out front of the parentheses. So this one we can evaluate. We'll get negative 7.07. So take the square root of 50, which is 7.07, and then put the negative in front. Okay, now part D, the square root of 121. 121 is going to be a perfect square. It's 11. 11 times 11 is 121. So you could write it like that, or you could just write 11. Either way is acceptable. Okay, last example then comes after our vocabulary words here. We have to talk about the radicand and then a radical expression. A radicand is when you have the stuff inside the square root. So if I had 4x squared, that stuff in there, that's my radicand. Okay, the actual symbol is called a radical. Oops, R-A-D. There we go, radical. And then a radical expression is going to be expression that's written with within a radical system. So that means you're going to have a square root in there somewhere. Now this I'm going to make an equation, but it also has an expression in there. Okay, and that one's pretty big. It's opposite b plus or minus the square root of b squared minus 4ac all over 2a. That's supposed to be a little a. It looks kind of sloppy. It looks like a c. Let me fix that. That's supposed to be an a. Okay, so this is what we're going to evaluate in example 4, these types of expressions. And when we're simplifying expressions, we basically substitute and then we evaluate. So we calculate our answer, and we want to follow order of operations. So we want to do PEMDAS. And instead of the parentheses, now we kind of have the square root. So the square root goes in there with the parentheses. Okay, so for part A, we're going to substitute first. So I'll have the square root of b squared, so that's 4 squared. And 4 times a, the value for a was 2, and c is negative 6. Oops. There we go. Okay, now inside our square root, it's kind of like one big set of parentheses. So in there we would want to do our 4 squared next. We want to do our exponent. And then we want to multiply the 4 and the 2 and the negative 6. So 4 times 2 is 8, times a negative 6 is a negative 48. So it would be minus a negative 48. But I need to change both of my signs there. So 16 plus 48 is going to be 64. Oh, well now I can take the square root of that and I will get plus or minus 8. Okay, so it's just basic substitution and then using our order of operations to simplify. And for our last one here, it's a little more complicated just because it's a fraction, but I'm still going to substitute the value for b, which is 4, and the value for a, which is 2. Now, a lot of times when students see this, they want to do 10 plus 2 first. Remember, you can't do that because that's addition. And here, in between these two, I have multiplication. Multiplication has to come first. So I could also simplify what's inside that square root, inside that radical from our parentheses. The square root of 4 is going to be 2, so this will be 2 times 2. And then 10 plus 2 times 2. 2 times 2 is 4. Now we can do the 10 plus 4, which is 14, divided by 2, which is 7. So as you simplify these types of expressions, just remember to substitute and then follow order of operations when you're simplifying. Okay, so this section is really just to get you warmed up to dealing with radicals, being able to understand what a square root is, being able to enter them into your calculator, to simplify them with order of operations. So it's building a nice foundation for the more complicated work we're going to do as we go through the chapter. So make sure you show as much work as you possibly can for these types of problems. And if you have any questions, come on in and see us before school.